Assume we have a normally distributed variable with a population mean of 20, a standard deviation of 1.5. We are asked to find the probability that any randomly selected data value from the population is between the mean and 22.4. So in probability notation, this is what we would have. The probability that any randomly selected data value x would be bigger than the mean and less than 22.4. So the first thing we need to do is draw a picture of that distribution with a mean of 20 and a standard deviation of 1.5. Then what we'll do is locate the data value 22.4. Since the mean is 20, the data value 22.4 would be to the right of that. Since we're looking for a probability then associated with this normally distributed variable, that probability will correspond to the area under the curve between the mean and this data value 22.4. So what we're looking for then is that shaded area. The first thing that we'll need to do is calculate a z-value. Remember that the formula for a z-value is z equals x minus mu over sigma. So we'll have 22.4 minus 20 divided by 1.5. This gives us a z-value of 1.60. We can use StatCrunch very easily to find this probability. Once we open StatCrunch, we'll press Stat, Calculators, Normal. And then this nice utility comes up that allows us to calculate probabilities associated with normally distributed variables. If we leave the mean at 0 and the standard deviation at 1, then we can use the z-value that we've calculated in order to find these probabilities. Notice that the area under the curve that is shaded will correspond to this value in the last box. So what I'm going to do is type my z-value in this box, 1.6, and then think about how I want to display that. If I'm looking for the probability that x is less than or equal to that value and hit compute, then I'm going to get 0.9452 if I go to 4 decimal places. But that's this entire area here. What I have to keep in mind is that's too big. All I want is what's between the mean, so in other words, what's between 0 and this 1.6 value. Now half the distribution lies to the left of this mean. So then really all I need to do is take this number, 0.9452007, and subtract 0.5. So this probability will be 0.9452 if we go to 4 decimal places minus 0.5, which gives me 0.4452. And that is that shaded area right there and the probability that we were looking for.